All right, welcome back to all of you. As I mentioned yesterday, this field of learning analytics is kind of a new name for an old thing, and people have been doing this kind of work for many years in many fields. But there is something that's clearly unprecedented about what's happening today. And I think it's the reason why we need something like a new name, like learning analytics, to describe what it is we're doing, a new banner to follow. The reason is really that digitally mediated education has made the measurement and collection of data about learners and their contexts a ubiquitous thing, something that just happens almost automatically. So if we take some care, we can observe and record both the process and the products and the context of student learning almost everywhere it happens, almost all of the time. The education process, in a way, is being instrumented so that information will be recorded about it all the time as a natural part of the process. And this is something new, I think, an opportunity to connect research and practice, to do research every time practice is going on, to have questions emerge from practice that then can be answered in research in a continuous kind of feedback loop. And I think it's the special task of learning analytics as a field to figure out how to capitalize on this opportunity. So when I look around, there is one group of scholars that are used to using regularly collected administrative data of this kind. And they're people who do research in public policy. Right? There have been administrative data systems gathering information about public policy questions for many years. And so researchers have been using that kind of administratively collected data, often with the methods of economics. Here at the University of Michigan, a lot of these researchers come together in different parts of the campus, but one unit that's particularly interesting to us is the SEERS group in the Gerald Ford School of Public Policy. This name, SEERS, stands for Causal Inference in Education Research Seminar. Right? That's their whole task, is doing causal inference in education research. And that pretty well captures what they're up to. They want to use data to draw causal inference about how education works, to really know that this makes that happen. Not just to observe what happens, but to do the kinds of measurements that allow them to infer causal relationships. They want to use data to show what works in really robust ways. So today's speaker, Dr. Kevin Stange, is a member of this group and does work that demonstrates the nature of their approaches very well. Dr. Stange received bachelor's degrees in both mechanical engineering and economics from MIT, and then a PhD in economics from Berkeley. He's currently an associate professor of public policy in our Ford School, where he teaches graduate courses on higher education policy, economics, and quantitative methods. He's also a faculty research fellow at the National Bureau of Economic Research, NBER, and a faculty affiliate of the Center for the Study of Higher and Post-Secondary Education and the Education Policy Institute here at Michigan. Professor Stange's research lies broadly in empirical labor and public economics with a focus on education and healthcare. His prior research includes studies of college enrollment and persistence, the effects of resources and peers on community college students, the importance of amenities in college choice, and the effects of different pricing structures on major choice and student credit load. This morning he's going to tell us about some more recent work, some of which uses the kinds of ubiquitous data which are emerging all around education. And I think there's a lot to learn from the methods that economic policy researchers use, and Dr. Stange's talk will provide a glimpse of how they approach these questions. Please join me in welcoming Dr. Stange.
Okay, thank you so much for that introduction, Tim, and thank you to Stephanie and Tim for giving me the opportunity to be here with you, and to all of you for coming, and also thanks, Tim, for the plug about our causal inference and education research seminar here at Michigan. So those of you that are local or even semi-local, meaning living somewhere in Michigan, you're very welcome to come to this seminar and get engaged. We have people that come from throughout campus and outside of campus. So feel free to talk to me afterwards if that's something of interest to you. I'm going to start with a question, if I can figure this out. Okay, so this is I'm going to talk mostly about a project that is aiming to measure instructor effectiveness in higher education. It's it's a joint collaboration with Peter de Vleger, who's a graduate student in economics here at Michigan, and Brian Jacob, who's a professor of economics, education, and public policy here at Michigan also. So let me just pose this question to start off. I teach. I think many of you probably teach. How would you tell if I was good at doing that? If I teach a class on quantitative methods here at the public policy school. How would you tell if I was good at that job? Yeah.
Students take a course that your course is a prerequisite for do well. They do well in the post-requisite.
So that, it turns out that's actually that's exactly what we're going to do on a sort of a big scale. So repeating that, this course actually prepares some students, or prepares students for some follow-up work, and you can sort of measure how well they do in that course. But what are some other possibilities? So that's what's that? Student evaluations. That's at Michigan. That's the primary metric we use, in actually many institutions around the country. How else? Yeah. Yeah, right. So you can imagine for, well, maybe for any class, having a sort of a pre-test and a post-test, and you can measure how much students learn. Any other ideas? Yeah. Right. So I think that's another great strategy that places, I think, don't use nearly enough is actually seeing what we're doing in the classroom. Observation, and maybe interviewing us and seeing how thoughtful we are about our education. Any other ideas? Yeah.
We try comparing the methods that are being used and the materials that are being used to what is shown by research to be effective methods and state-of-the-art kinds of materials. What you're actually
doing. Yeah, it's a great suggestion. Yeah. Any others? Let's take one more. Yeah.
Students are so excited about the work, you can't get the math and get them.
Sorry, say that one more time.
The students are so engaged in the hopefully collaborative group work that you're running with it, you can't get the math and get them.
So you could sort of measure their enthusiasm at the end. They won't leave when I'm done talking, even though I say to go. Yeah. Which is, in some sense, a qualitative version of asking them how happy they are with. So these are all, I would say, different ways that people have sort of tried to attack this problem. In this project, as I alluded to in the very first response, we're going to take an approach where we're going to try to measure learning by looking at performance in subsequent courses, but in sort of a big data learning analytic econometric approach. Whenever you sort of see a bunch of dashes, that means it's kind of a not very clear concept, and I'm trying to mush a couple things together that maybe shouldn't. But that's my idea. Is this working? No. Okay. So let me give you a little broad context. So I'm a policy, at a policy school. I'm motivated to answer policy relevant questions. Broad policy context is there's just, everywhere you look, sort of heightened concern about students' performance, sort of dropout rates, high levels of debt, students not being able to get a job, and that's really led to greater push for accountability to institutions, higher ed institutions, both by regulators who at the federal and state levels, funders who are paying for it, not just the regulators, and then also sort of students and parents who are also sort of have a lot of skin in the game. And so, I think this is, even since I've been sort of doing this kind of work, there just seems a proliferation of interest and search for policies to help students perform better, coming from many directions. So the setting I'm going to look at is University of Phoenix, which is a big for-profit institution, which I'll talk a little bit more about. So they actually are doing more and more of the kind of work that you all do. And I think the motivations come from a couple different directions. So here are a couple motivating events that led to this. So they've been under scrutiny more than anybody else, probably along all the things I've been talking about. They really have been sort of looking for ways to improve their students' performance. Their former president, so the president up until a couple months ago, actually was our former CFO from U of M, took a job there, and wanted to make a bunch of changes, including more attention to student success. Also the recognition that, as Tim was describing, the University of Phoenix has just an amazing, unparalleled wealth of data about their students and their learning environments. And then Tim McKay was involved in this in some way. This was before I got involved, meeting with Phoenix and doing what he does, I guess. And this led to a number of things, including a partnership between University of Michigan and the University of Phoenix to do learning analytics. And then after that, actually, they've established sort of a center to do learning analytics research at University of Phoenix. And then this study is sort of one consequence of this whole collection of events. So we're going to, as I mentioned, look at instructors. And I guess the viewpoint that I come from is that there's a lot of focus on student success, and the idea being that there's professors and the instructors are one of the major inputs into into the sort of higher education production process. So student effort is a big one. These buildings and the instructional materials are another big input, but certainly instructors are a big cost and potentially a big important input. And so the question is, could we use instructors more effectively to improve student success? And I apologize that I keep looking back. So usually there's sort of a screen here that shows me what's going on, and there isn't one here, so that's why I'm kind of looking back occasionally. I do most of the work in higher education, though I do have some familiarity with the K-12 education literature. And there's pretty compelling evidence that teachers are important to student success in primary, secondary, elementary school. And this is just a couple studies, but I'd say a consensus estimate is that if you take sort of an average teacher and replace her with one that is a standard deviation better by some sort of quality metric, that will result in a 0.1 standard deviation improvement in students' performance on standardized tests, for instance. You see this in a number of different studies using pretty sophisticated methods. And there's also been a push to use these measures by school districts, states, and schools to identify and reward effective teachers. So I'm not going to get into whether I think that's a good idea or not. There's a lot of problems there. But the recognition that that teachers are important seems to be pretty borne out in the literature. The thing is, we really don't know much about this question from higher education. So what we do know is from a couple random studies at select institutions. So there's a pretty compelling one from the the U.S. Air Force Academy that finds that instructors sort of are important, but less important than we see in sort of the K-12 literature. On the other hand, there's a study from DeVry University that is quite similar to the University of Phoenix in terms of structure that finds instructors are really important, that about a 1 standard deviation improvement in instructor effectiveness is associated with a 0.3 standard deviation increase in students' test scores. It's lower for online courses. There's less variation there. It's pretty mixed evidence on whether or not this effectiveness correlates with anything that you can observe in the data, actually. But there's a lot of challenges, I think, that have prevented this kind of work from really making inroads in the higher education sector. I'd say the biggest one is that there just hasn't been data, actually, that links students to their instructors in higher education. There's been a lot more of that in K-12 than there is in higher education, up till now, historically. But there are other sort of big conceptual kind of problems, too, right? What outcomes should you measure? The fact that students can choose what school to go to, what classes to take, who to take those classes from. There's just a lot of non-random sorting that causes some problems. And then there's attribution problems, given that people have many instructors for many different subjects, and how can you tell that the performance in your subsequent course is really due to me and not to the 3 other instructors you had in the previous term. So there's a lot of issues, which I'll talk about as I go along here. So the research aim of this project has been really in two phases. The first phase, is which I'm going to talk to you about, is really just quantifying the variation. How important are instructors to student success? Do these things, the current sort of system for evaluating instructors, namely course evaluations, does that have any bearing on, does that actually pick up sort of effective instructors or not? And then we've started to do some stuff that looks at sort of how effectiveness varies with things like experience teaching the course. But going forward is in some sense where the real learning analytics is going to come in. You know, the fact that we actually have really rich data about the instructors and who they interact with and how frequently and the quality of those interactions, particularly for the online setting, but even for the in-person setting, will let us say things, or examine things like what behaviors and attributes of the instructors characterize the more effective ones. And then I'm at a policy school, so I'm interested in sort of what policies might we enact that would improve effectiveness, either by attracting better instructors, retaining the good ones, motivating them to do different things. So that's where we're going. Okay, so I'll have a couple ramblings about education policy evaluation. I think Tim did a much more coherent setup than I will do. But then I'll sort of get into the study itself, the Phoenix context, the data, the sample, and then what we did with it, and what we found. Okay. So, you know, as Tid said, I mean, people have been studying how students' success or attainment is correlated with various policies for quite a while. But I would say, you know, prior to, at about 15 years ago, most of that work was really focused on fairly blunt policies, like average tuition of. Move it up a little bit. Okay, thanks. Sorry about that. Yep. Yeah, thanks. Has been focused on pretty blunt policies, like average tuition in the state and its effect on how many kids go to college, or when the state cuts appropriations for higher education, what effect does that have on students' graduation rates or time to degree? And most of this analysis is used fairly unspecialized data, so aggregate state-level enrollment rates from the CPS or something like that. Or sometimes microdata, but from nationally representative surveys, which are pretty small, not exclusive to one set of institutions, and so it's really going to be hard to know anything about these students' environments. And the outcomes that people have looked at have mostly been attainment, how many years of schooling you get, do you get a degree, sometimes achievement, where we now have sort of test scores, less so in higher education, or earnings. I still think these are important outcomes, but I'm a bit biased because I'm an economist, so I tend to think about these kinds of outcomes. But I'd say this kind of work now, I mean, it's really had a sea change in the type of work, type of questions one can answer, and the methods used to answer those questions. So the work now has been much more focused on really targeted interventions, like the effects of taking a particular course, like getting assigned to development math courses when you enter college versus just mainstreamed. The effects of like nudging to improve students' study habits. The effects of sort of taking a course online versus face-to-face. So this kind of analysis really takes advantage of sort of micro-administrative data that has rich information about who gets a given treatment and why. Like, why did certain students get assigned to a developmental math course versus not? Rich data on the courses they take and their performance in those courses, and rich data on, and this is, I think, the real frontier now is rich data on in-course activities, about the learning environment, which help you pin down kind of mechanisms. The goal of this work now has really been to, not only assess the effects of these policies, but also to get inside the black box to understand how are those policy effects sort of operating, what are the channels. And not to poo-poo this kind of work, which is I still do this kind of work, and this is still being done, but I think this is less at the forefront than the kind of stuff that's characterized here. Another, I'd say a theme throughout all of this kind of work has been the application of modern microeconometrics, which is basically just the application of statistical methods to answer causal questions, to infer causal relationship. I'm going to use that word causal a bunch, actually, in this talk. I'd say the defining features of this approach is really focusing on specific causal questions rather than sort of general outcome determination. So questions like, does this particular intervention improve students' outcomes, rather than what determines student outcomes? A lot of things determine student outcomes. But I'd say that the econometric approach really sort of narrows in on a narrow set of interventions or treatments, one might say, and really focuses on research design. So understanding kind of why do certain people get the treatments, and why do certain people not get the treatment, and how might the reasons for getting the treatment be correlated with the outcome? Because if so, that's going to be a source of bias in your analysis, and really coming up with ideas and approaches for dealing with those issues. And then statistical inference, I mean, that's just making sure that the patterns that you see reflect a real underlying relationship and not just chance. But that's that's certainly not exclusive to econometrics. Okay, so that's I would say this study is going to be characterized by a number of those themes that I just highlighted. The context we're looking at is, as I mentioned, University of Phoenix. It's the largest university in the world. I think that's still true. They've been declining enrollment dramatically in the last couple years, but I think that's still true. It's an open access institution, for those of you not familiar with it, that's for profit, that has, this might be surprising to many people, actually, a large physical presence also. So it's not just online. That is a big part of their model, but it's not exclusively online. And certainly in its historically, actually, it was a bigger ground presence. And very large geographic reach, has many campuses across the country. And we thought this would be a good setting to look at instructors, A, because it's just huge and there's a lot of them. But also, the Phoenix, if these kind of performance-based personnel policies that you start seeing in elementary schools and secondary schools could be enacted anywhere in higher education, this is the place. The faculty are contingent, the courses are frequent, so you could actually get pretty good measures of instructors' effectiveness. We're going to look at a single course, or two course sequence. We're going to look at college algebra, which is called Math 208, and then its follow-up course, which is Math 209. It's basically just algebra. Think of just algebra. It's required for all bachelor's degree students, and it's perceived as a huge barrier to students' progress towards degree. That's not exclusive to Phoenix. I mean, this is true everywhere in higher education, that this course is a barrier to students' persistence. And then, we have Math 209, which serves as a measure of how much students learned in the earlier course, because this is a required course for anybody that continues. It's got a standard curriculum. Instructors can alter it a little bit. This is something we're trying to get more traction on. We have the sense that they really just don't. They use the canned curriculum. They use the canned assignments and assessments. And so actually that's useful from our perspective, because now we know that basically the only thing that's differing across students really is the instructor and how they deliver the content. Okay. The sample, so we went back to 2001 and got basically all the Math 208 sections that were ever taught, all the instructors of those sections, and then all the students who ever took those classes. And it ends up being about 26,000 different sections over this time period, just for this one course, which ends up being about a little more than 2,000 instructors and 300,000 students over that time period. So if you divide 26,000 by 2,000, these instructors actually teach this course quite a bit. And we have end-of-course assessment for a subsample of the data, the last 5 years, as well as end-of-course student evaluations from a similar time period. It ends up the sample, whether we focus on just this more recent sample or the whole sample, it doesn't really matter. You get basically the same kind of patterns. So we're going to harness, I guess to a group like this is less compelling because you all are doing this kind of work already. But it is fairly novel, and as I mentioned, in kind of the policy analysis realm to have this kind of rich administrative data. So about the instructors, we've got some demographics, not great demographics, but pretty good information about their whole teaching history at Phoenix and when they were hired. So we can think of things like experience pretty precisely. Students, we got some of their demographics, their program, their full transcript before and after taking this course. We have some information about the sections, namely what campus it's taught on, both, which includes online as a campus. Start and end dates, who the instructor is, what the total enrollment is. Some of the main weaknesses of the data is many of the demographics are just not that well measured. And we've got good information within Phoenix, but pretty bad information about what goes on outside of Phoenix. And that's true both of the students and of the instructors. So most of the instructors are doing a bunch of other stuff other than teaching Phoenix courses. We don't have a great handle yet on what those other things are. I'll talk a little bit about how we're going to try to fill in that gap. And same thing for the students. Many of the students are, as you'll see, are older, and most are working. In fact, that's the origins of Phoenix, was to serve precisely those students who were underserved in the traditional higher education system. And so actually not knowing what the heck is going on in the rest of their life is actually a pretty big weakness in this setting relative to other settings with more traditional students. But I think, anyways, that's an area that we're pushing on. So just to give you a sense of who these students are, in this particular course, so 2/3 of them are female. The average age is 35 years old. So one thing that's kind of interesting, though this is an introductory algebra course, students have actually taken many courses before they get there. So they've taken a bunch of courses prior to getting into this course. They've taken 23, 25 credits. This just splits it between the face-to-face sections and the online sections. Since these are students that sort of persisted to get to actually this course, they're actually positively selected. Their average GPA is about 3.3 relative to the average of about 2.8 or something in general for the population. Most of them are in pursuing a business bachelor's, and you can see the others. Okay, that's the students. The instructors in the sections, most of the instructors are male, actually, in contrast to the students. The sections are really small. They average about 13 students. And the instructors have been teaching for about 5 years. They've taught this course before about 15 times. And they don't get paid very much. $1,000 per course is basically what this is. Okay. Oh, there was one contextual thing which I don't think I mentioned here earlier. Students take basically one course at a time for 5 weeks. And so you see sort of a lot of courses sequentially. So think of this not as sort of students are taking 5 courses or 4 courses or 3 courses, but rather they're taking one course, and they take in a short period of time. And same thing for the instructors. Instructors are typically teaching 1, sometimes 2 courses at a given time, but they teach a lot of them in the course of a year. So you could teach like 10 courses a year, but it's usually 1 at a time. Okay. All right, in terms of methods, so how are we going to actually figure out who the more effective instructors are? I need to speed up a little bit, I think. So obviously there are many factors that influence students' success, students' preparation, effort, other things going on in their life. We're interested in isolating the effect of instructors from all these other things. So how do we separate the contribution of instructors? So here's a little thought experiment. So suppose you had 100 different instructors, and you had them teach exactly the same set of students at the same materials, at the same classroom environment, at the same time, and then you measure those students' performance afterwards. Well then, any difference in student outcomes between these 100 instructors would be due to the instructor itself, not to the students. The students are the same, materials are the same, the course environment is the same. If you repeated this a bunch of times, you'd get a pretty good idea of which are the effective instructors and which ones are not. That's the idea. Obviously, this is impossible. You can't teach, once they've taken this class, they're not the same students anymore. So we're instead going to use statistical analysis to approximate this hypothetical scenario, coupled with the fact that essentially what instructor you get at University of Phoenix is random. It's truly random when you're talking about online. Like, they literally just randomize which section you get put into and which instructor you get. In the face-to-face sections, we do a bunch of stuff to sort of convince ourselves that actually it is pretty random too, that there's no sort of systematic patterns to which students are taking courses from which instructors. And that's what we're going to do. So let me give you a few mathematical details of this. So the standard, it's in some sense a standard value-added model that has been used in K-12. So we've got some outcome for student I taking a course, section J from instructor K at time T, and then we're going to control for a bunch of characteristics of that student and some aggregate time trends and campus differences. It turns out none of these things matter. Like, they all influence the outcomes pretty strongly, but controlling for them actually doesn't matter, which gives us some faith that actually it is pretty random which instructor you get. And then there's other random influences, and we're going to try to estimate basically this these thetas, theta k. So that's basically the systematic contribution of instructor K to their students' performance. If you observe an instructor teach multiple sections, then you can separate the fact that that instructor really is a good instructor from the fact they just got lucky and got a good group of students, even sort of conditional on their students' characteristics. It's possible that even, for two sections, one of which had the same sort of students' preparation coming in, one just happens to do better for whatever random reason than the other. Well, you don't want to attribute that to the instructor. But if you observe the instructor getting enough of these sections, all that kind of randomness will even out. And what we're interested in is basically, we're not yet interested in sort of precisely knowing the contribution of Kevin specifically, but rather how important is our instructors generally? Like, what is the distribution of these instructor effects? That's what we're interested in. And we're going to estimate something, effectiveness in teaching Math 208. Or sorry, these are all Math 208 instructors. They're all sort of instructors in the earlier course. And we're going to look at sort of performance in that course, but then also performance in the subsequent course. So you can imagine instructors are teaching just the material that's going to help them do well in that course, but it doesn't translate to the follow-on course. Or you could imagine some instructors teaching them material that's going to be really useful in the subsequent course and less useful in the follow-on in the current course. So we're going to allow that and see how correlated sort of me teaching, my teaching is to students' performance in this course here versus the next course they take. Okay, a couple challenges, and I could spend a lot of time talking about these, but I want to get to results. Outcome measurement, we're going to focus, so big challenges I think are these two, the non-random assignment of instructors to the students and the outcome measurement. The fact we have instructors in many different campuses makes us want to compare them across campuses to sort of separate the Detroit campus effect from the instructor's effectiveness at the Detroit campus. So that's something we're going to be able to do here. So outcomes, we actually don't have great, I don't know if you think of these as learning outcomes. We have grades in the course, and we also have performance on standardized tests in the course, and then those same things in the follow-up course. And we also have longer-term outcomes that are definitely beyond the instructor's influence, like how many future credits they earn, whether they stay in the program, and we're also going to look at course evaluations. Okay. These are these outcomes. There's not really a whole lot to say here other than a decent number of people don't finish. The withdrawal rate is 12%. It's a little higher for online courses. You see that in basically every online study that I've ever seen. The online courses have a higher dropout rate, but they're actually not that terribly different, in the big scheme of things. Okay, let me just skip this actually. So I mentioned a couple of the outcomes that we're going to look at. So the second big issue is just student and instructor assignment. So you worry that certain students are going to seek out the better instructors, and those students are not a random sample potentially. And so you might be worried that it's not just the instructors, it's the quality of the students they're getting. That could go either direction. You could have the good instructors matched to the less prepared students, even sort of conditional on students' grades coming in. So all this is going to be conditional on students' grades coming in, but you could still imagine this happening. In this particular setting, there just seems like there's very little room for this. We're going to do a bunch of tests to convince ourselves that that's true, but in general, you would need to worry about this if you're going to do this kind of study in higher education. So I'm going to pursue this study here at University of Michigan, and this issue is going to be a lot more salient, I think, in our setting here than at University of Phoenix. Because instructors know or students know who's teaching what courses, and they might select those courses based on that. So we've done a bunch of tests. So first, do the high-achieving students, as measured by their grades coming into the course, match up with more experienced teachers, teachers that are more likely to be or teachers that are male, teachers that are have been at Phoenix longer, and there basically are no correlations between any of those variables. So that suggests that there is some randomness to it. You could also look at whether or not the students' characteristics are distributed as they would be randomly. Like if you just really randomly assign students to instructors, you'd get some distribution of what those sections look like, and it turns out that the real data actually looks like that. So that's another piece of evidence. And also, we control for a bunch of characteristics of the students, and if students are really sorting into better instructors, those controls would really matter. It turns out they don't. So that's another piece of evidence. So I think this is the kind of thing that, this is the kind of checks that are economists and people doing econometrics like obsess over. This is like all we do. We spend a lot of time worrying about those issues, less time worrying about measurement, less time worrying about or talking about the actual results. We spend a lot of time talking about these issues. Obsessive focus on causality is one way in which I think the modern econometric differs a little bit from some of the learning analytics work that is more interested in kind of prediction. So what are the best predictors of these outcomes? Econometrics approach sort of takes a bit more focus on like, well, a given explanatory variable, does it cause the relationship that we're seeing or not? We need to rule out a bunch of other possible confounders. We need to rule out that the better prepared students are getting assigned to certain instructors. We need to rule out that other supports are being assigned to the instructors that we're measuring as being better. There's a bunch of various approaches. This is in some sense, a random experiment that was just done by the nature of the operation of the institution. You can imagine doing explicit random experiments, or natural experiments like this one, or just lotteries. Sometimes when a program is oversubscribed, you could see this actually in like nursing programs in community colleges are always oversubscribed. Often admissions based on a lottery. You could look at the people that win the lottery versus lose the lottery. Or just quasi-experimental methods, regression discontinuity, or difference or matching. So these are all approaches that I think are in the econometric vein to try to get at causality. And I'm happy to talk more about this offline or in the Q&A. Just skip that. The last issue that comes up here is comparisons across campuses. So you might worry that observable differences between students, that the students in Detroit are different than the students in Albuquerque on a number of dimensions, and so how can we say that the instructors in Detroit are really better than the instructors in Albuquerque, and that it's not just something about the students? And so what we could do is sort of basically control for campus differences. We include sort of a huge set of campus control for the average differences across campus. And it turns out that sort of separately identifying these campus effects from the instructor effects, you need instructors that are teaching across different campuses. And you need this sort of the whole network to be connected. Well, it turns out that there are something like 10% of the instructors are teaching at more than one campus, including the online, though that's not all coming from the online. So this, you can see, this is just splits instructors by whether they never taught online versus they did teach online. And then the bars are basically how many ground campuses they teach at. And you can see that most of the instructors that never taught online, they only teach at a single ground campus. But there's a couple hundred that teach somewhere else also. And then of all the ones that teach online, most of them only teach online, but there's a number that teach at a physical campus too. And so if you look at the network, it turns out that all except for 8 of these campuses are connected to the network in some way, with the online node being kind of the most central, because a decent number of instructors teach online and on campus. And that lets you compare them. But even if you get rid of the online campus, there's enough connectedness you could still do this. So the Southern California campus, there's enough instructors that teach there, and then at the Phoenix campus, and there's people that teach at Phoenix and Albuquerque, and there's people that teach, and you could sort of chain your way all the way to Maine. And that way you could compare instructors in one place to another. Okay, so those issues I think we're able to deal with here. So I mentioned that, now I'll get to results. I mentioned that like controlling for these variables like students' GPA coming into the course or their age, they don't really matter. I want to be a little more clear. They don't matter in terms of how our conclusions about how important instructors are. They really matter in terms of predicting student success. So this just regresses, it shows the correlation between these characteristics of the students and their performance in Math 208. So say if you look down at their GPA before coming into the course, in other courses, like not math courses, 1 point increase in your GPA is associated with a 0.74 increase in your Math 208 GPA. That's not surprising. Students that are good in every other course are also going to be good in this course too. And age is also a big predictor, and there are gender differences in this course. But there's a bunch of, and then we also merged in characteristics of the zip code the students live in. So being from a lower zip code that has a higher poverty rate makes you less likely to, or you don't do as well, as you might expect. So these are important, but it turns out they just don't, including them doesn't control, they're randomly assigned to basically instructors. Some instructors get a big mix of students, basically. So here's some of the results. Let's get to place here. So again, you remember the thing that we're interested in is basically the distribution of these instructor effects. Like how important is our instructor effects broadly? And the way we think about quantifying that is a 1 standard deviation increase in instructor effectiveness by this measure, how much does that increase students' performance? And the answer to that is about a 0.3 standard deviation increase in their course GPA in Math 208, and then a smaller but still large 0.2 increase in their performance in the follow-up course. So the way to think about this is if you replace the average Math 208 instructor with one that is 1 standard deviation better, so what that means is replace the the middle one with an instructor that's at the 87th percentile, is what a 1 standard deviation increase would be. That's going to be associated with a 0.3 standard deviation increase in their Math 208 grade, and a 0.29 standard deviation increase in the Math 209 grade. We standardize these grades so that they could be comparable across different outcomes, but you could think of these as almost like GPA points. These are a little smaller than GPA points, but in the big scheme of things, you can think of them as increasing it by 0.3 GPA points. Or taking someone, replacing an instructor that's 1 standard deviation below the average with 1 standard deviation above will take students from a B- to a B+, is how to interpret that number. That's overall. These last 2 columns here do it separately for in-person courses and online courses. And you see greater variation for in-person courses than online courses, but still significant amounts for online courses. And one thing that's not represented here is that we find that there's a positive correlation between students' performance in your course and in the subsequent courses. So if you have an instructor that's good at getting people to do well in Math 208, those students are also going to do well in 209, even if they have a different instructor. And so the learning is sort of persistent in this context. This says, well, you might worry that grades are not a good measure, particularly in the course current course, because it's subjective, and there are grading rubrics and standards, but it's somewhat subjective. So we could also use basically test score performance. There's a standardized test that's given at the end of these courses. Again, the instructors can tweak it. In practice, our sense is that they just don't. And so we think of this as a pretty good standardized test that is common across all the different sections that the instructors really are not tweaking too much. If you use that as the outcome, which is probably more objective, you get the same result. In fact, actually you get bigger effects. So the estimates tend to be like 0.4, 0.5, and again, smaller for online. Okay. So how do we interpret the magnitudes of this? I already gave you a little bit of that, but what does a 0.41 standard deviation increase in test scores mean? Well, remember, these student characteristics are also really predictive of their performance. And so you could think about comparing these estimates to the effects of other characteristics. So remember, older students tend to do worse. Students with higher GPAs coming into the course do better. And so replacing an average instructor with one that is one standard deviation better is going to be like, it's going to actually be larger than the gap in performance between 25 and 35-year-olds. And it's going to be similar to the gap between students coming into the class with a 3.0 versus a 2.0. So, right, so getting sort of an instructor that's sort of, replacing the middle median instructor with or average instructor with one that's sort of at the 87th percentile is like sort of boosting students' preparation by a whole GPA point coming into the course. So that's pretty large. We looked at some other outcomes. So you see, significant effects on passing Math 208, and then these show basically the effects on likelihood of taking Math 209. So having an instructor that's sort of one standard deviation better is associated with a 5 percentage point increase in the likelihood of taking the follow-on course. So all these students have to take the follow-on course if they're going to graduate with a degree. And so you think of like, well, do they take this course as a pretty good measure of whether or not they're going to persist to the degree. And it turns out having a good instructor actually makes you more likely to persist. We also could look at sort of number of credits earned in the subsequent 6 months as a measure, as an outcome that's not really, it can't be influenced by the instructor directly. And so we think of this as and this is actually probably the outcome that Phoenix is most interested in, because they want people to stick around and keep taking courses and pay. And so you see a similar pattern there when you use that outcome. Okay. Like we said, like I said, most of the correlation between these different outcomes is similar. I guess the last piece of, I think I have 2 more pieces now, so I'll wrap up in 7 minutes, I think. Does that sound good? Student evaluation. So Phoenix, I was actually surprised by this. They have essentially the same exact evaluation system as, say, University of Michigan. I mean, the questions are different, but basically they ask students at the end of the course, just like, how much did you like this course? Would you recommend it to somebody else? On a scale from, in their case, 1 to 10. And it's optional. Not all the students have to take it. And this is kind of one of the primary metrics they use to evaluate instructors. They do some other stuff too. They do some actual classroom observations, as someone mentioned. Once a year, they look at the student's performance in the course. So if you have a bunch of students failing, they're going to look at that instructor. But this is one of the big measures they use. So we're going to look at this question: how well do you recommend the instructor to somebody else? Even though students can't really pick instructors, but do you recommend the instructor? And we're said, if they got an 8 or above, let's call that yes, and then anything below that is a no. It doesn't really matter how you code it up or which actually question you use. They're all fairly highly correlated. So we were wondering, if we do the same kind of exercise where we estimate, well, what are the instructors that are judged to be effective based on this criteria? You get kind of a ranking of instructors. You could do that controlling for student characteristics or not, doesn't really matter. Well, how does that correlate with the ranking as measured by these other measures, like performance in the subsequent course? It turns out not very highly. So these are the correlation coefficients between ranking by the evaluation system and ranking by the course performance measures. And so they're most highly correlated with students' grades in the Math 208 course. Teachers get rewarded with good evaluations if the students do well. But you worry that that's the most subjective of all these outcomes, right? Because grades are determined by the instructor. But if you look at more objective measures, like their performance on the test or their grades in Math 209, you get a lot lower correlation. This is insignificant. So the performance on the end of course exam in Math 209 has like no correlation with your evaluation scores in Math 208. So we did a bunch of things to sort of convince ourselves, and there's a paper I could share with anybody who's interested in. It's on my website, but I could also send it to you. That has a lot more technical details and robustness and stuff, but we do a bunch of things, and we still find this same pattern. For instance, worrying about section-specific shocks, having whether some instructors in Math 208 also teach the 209 sections, at least in the ground campuses. So you might worry that there's something about these instructors that doesn't change anything. Anyways, none of these things change our results, basically. There's a lot of little details you have to worry about. Like some students don't actually take the following course in the following course exam, so you have to make assumptions about what they would have gotten. It doesn't really matter what assumptions we make. Anything that's reasonable that we could possibly throw at it gives you the same basic patterns. And then the last piece of analysis I'll do is just, we were interested in how does effectiveness correlate with stuff. So we look at experience, so number of times teaching this course, that's what's on the x-axis here. And this is sort of effectiveness. And so here we've let it vary over time. So we can measure instructor effectiveness in every semester. That's really noisy, so in general you don't want to do that. But if you want to look at how that evolves over time, you can do that. And so we see some boost up in effectiveness when instructors, the first couple times they teach the course, but then it kind of flatlines after that. So we're digging into this a lot more here. Large differences in instructor effectiveness. It's greater for ground than online campuses. It's really not well captured by their evaluation system. I don't think I mentioned, but so basically University of Phoenix, they just pay their instructors a fat fee, at least for this course, that doesn't really depend on much. You've been teaching a lot, if you've been there a long time, you get a little bit more, but pay is certainly not correlated with effectiveness. It's not even actually adjusted for cost of living across geographies. So it's almost exactly like $1,000 everywhere for everybody that's teaching this course. You might wonder if that's a good policy. Maybe they could attract more people if they paid, or better instructors if they paid people more in the more high cost of living areas, for instance. Or the instructors whose students systematically do well, if they paid them more, they would stick around. These are policies that we're interested in exploring going forward. We find instructors seem to be really important in this context, and we were initially kind of wondering, is this too big to even be believable? It seems to be more important here than in K-12. And we started thinking about it. I mean, some of the explanations we come up with is that these are pretty contingent faculty. They don't get a whole lot of training. There's some training, but so you can imagine a huge variation in where these people are coming from in their preparation for teaching this course. It could be something about the students. We think that the scope, or the fact that these classes are really condensed, that could actually magnify any differences across instructors. So if instructor doesn't respond to feedback, doesn't provide feedback to their students for a week, that's like the whole course. I mean, the students are really going to be badly off. So we're interested in exploring those kind of mechanisms. So we think this study sort of documents like there's potential for improving student success by doing something to improve the instructor's effectiveness. And that the current evaluation system says it's not really capturing that. The key issue is what makes an instructor effective, and then how can we identify them and retain them. And so that's where we're going in the follow-up work, is to just better understand who the effective instructors are and what background they're coming in with, what kind of engagement do they have in the course. In the long run, we want to look at some of these policies. What are the most effective instructors doing right? What are the least effective ones doing? And then what characteristics predict effectiveness? So the way we're going to attack this is kind of a mixed method study. I'm just a quantitative researcher, but they have a couple qualitative researchers at Phoenix that we're partnering with that are going to lead the qualitative work. So it's going to be a couple pieces to this. So I'm going to do a sort of deeper quantitative analysis of, we got more information about the instructors, more about their education and their work experience prior to Phoenix, outside of Phoenix, that we'll be able to code up. But I think more interestingly is, as Tim described, like every way that the instructors and students interact in this environment is captured in their data warehouse. Certainly online, but even the face-to-face one captures a lot. And we're going to start coding, mining that for even basic things like how frequently the instructor provides feedback, some measure of the quality of that feedback, the timeliness of it, and who knows what else is in the learning management system that we could look at. We're also, I think that's only going to get us so far. There's also just a bunch of holes in our knowledge about who these people are and what they do that we'd like to fill with survey information that we could then link to the students' course performance. So actually there was a theory that the people that actually have a math background, like there's a decent number of people that have masters in math or PhDs in math that are actually teaching here. They're going to be the least effective instructors in this setting, and that the people that have education backgrounds are actually going to be more effective. That was their theory. So that's something we could test. I don't know if that'll be borne out or not. We also are going to do some focus groups and interviews with students and instructors just to get a better sense of qualitatively how these instructors are different. Okay, so a few final thoughts. I mean, I've sort of come at education research from on a pretty high level policy question. So in this case, do the personnel policies that Phoenix has or doesn't have a very terribly sophisticated personnel policy, does that have a potential, do changes in those policies have potential to improve student success? This led us to examine the role of instructors in students' academic outcomes. Now we're really digging into more into what the instructors are actually doing to alter the learning environment and how these are affecting the students and how they're interacting with students. And I think our goal, this is where sort of policy education policy analysis is kind of meeting learning analytics, is that we're sort of moving from this really high policy level where we don't have a great sense of actually what's going on inside the black box to trying to drill down to better understand why these policies might work or might not. And I think that really starts to become a learning analytics task. Thankfully, there's a learning analytics center at University of Phoenix that is interested in doing this kind of work. Okay, so thank you again. Now we have some time for Q&A and stuff. I'm here and accessible. This is my contact information. Like I said, people interested in this study specifically and many of the details of it, I'm happy to send you the full paper, or you can find it on my website. So that's it. Thanks. Yeah.
Your approach using a coefficient to your solving for getting the equation there, it seems that approach would actually resolve the relative difference between professors rather than the absolute. So rather than being absolute quality, it's dependent on there being variation among professors. And that number would change as the variation goes down. So if you adopted policies, for instance, that made everybody worse but more equal, you would also see the numbers sort of go down. So how would you, as you try to adopt the policies, ensure that you are bringing everybody up and together rather than simply just together?
Yeah, this is a great question. And this came, when we presented this at Phoenix a couple months ago, this was like a big question that they wondered. And so let me just let me repeat the question, or statement, I guess, both, I suppose. So first is the statement, the observation that what we've really captured here is a relative ranking. I mean, we're able to sort of rank them across the whole all the campuses across the country, so that's useful. But still, we can't say anything about how University of Phoenix instructors compare to University of Michigan instructors, or to the effectiveness of this new instructor that they might hire or replace their current ones with. So that was the statement part. The question is, how do we deal? How can we be sure that students' success, or if effectiveness is actually going up relative rather than even when you change the ranking? I think that it's a good question. I think you can still. So I think the answer is, if we have some instructors that are still there, we can be able to say if we change the policy that sort of brings in new instructors, for instance, or gets rid of some instructors, we can, as long as we can still compare those new or leaving instructors to our current body, that'll tell us whether or not the instructor pool overall is getting better or worse. Though I think your point is exactly right, though, is that we still can't be able to say about how that pool of instructors is going to be comparing to some other pool outside. But I think better understanding sort of whether the marginal new instructor or the marginal instructor that's leaving is better or worse than our current stock will still tell us whether or not the thing is improving or not. But it doesn't, so it gets around the issue that you mentioned, which is that we don't know anything about absolute effectiveness. But I think it does tell us the direction, which I think is ultimately what we care about for policy. Yeah, because I think we wouldn't for policy. I don't know that we would necessarily look at like how the distribution is to change. I mean, we might look at that, but that's not going to be the thing that's of primary interest. I think what we want to know is whether that distribution is moving up or down, even though we still don't know whether it's where it is. Yeah, that's an excellent point. Yeah. Other questions? Yeah.
How can we get your paper?
Excuse me?
How can we get your paper?
So it's on my website, but you could also send me an email and I'll send it to you. Yeah, sure thing. Yeah.
Just wondering, do you have a sense of how big the random other term is in your model? I'm thinking of things like rooms next to instruction sites or classes held at 6 p.m. on Friday evening, or those kinds of other effects that may not be in the model itself that have sort of been lumped into other non-instructor effects. How big is that?
So,
Sense of the effect.
do you, so was your question these other things like having construction site next to your classroom or whatever? Is your question, are those things lumped into the instructor effects or how big they are? Right, so that's going to be the error term. Yeah. The question is how big.
Do you have a sense how big that is?
Oh, yeah. So the question is how big are those factors? So, yeah, actually, I didn't include this in here, but where that shows up is we actually estimated the variance of those error terms. It is how I would operationalize that, and I want to say that those in aggregate, those shocks, those errors are the variance of those is actually comparable to the variance of the instructor effects. So that's another way to sort of think about the magnitude of this, is that if you think about all those other kind of error things going on, the classroom temperature, construction going on outside the door, those kinds of things, the instructor effects are about as important as those things. And that's sort of after netting out all these student characteristics like students' preparation and their socioeconomic status and the campus they're from, these kinds of things. But that's a way of quantifying that. That's a good point. Yeah, Tony.
So one of the things that we say in the solar definition about learning analytics is that it's in service of using the data, having the data be actionable. And selling learning analytics to instructors, if you talk about it solely as a means of identifying good instructors, where the implicit outcome or action is we fire the bad instructors, that really out to be as important as the instructor effectiveness itself. I'm just wondering, so where do we go with this?
Yeah. Great. Thanks for giving me the opportunity to clarify. Yes, thank you. Because actually, and I found this encouraging. When we talked to, when we sort of presented this at Phoenix, their action is not, and we really pushed them to this. Their policy response was not, let's go identify the least effective instructors and fire them, but rather, let's see what they're doing, how that's different than the others, and have some intervention that changes that. I guess if there are still instructors that still don't quite ever kind of get on board, then that dismissal is one route. But there are many other sort of incentives, and this is, I think, where we want to go in the next sort of phase, is other things you could do with this. So you may not punish sort of ineffective instructors, but you might reward either, forget about monetarily, but like with more sections. So actually the ability to sort of teach when you want is a perk that they dole out now, mostly based on seniority, but it's not terribly systematic, and that's something they can make much more systematic. Yeah, because I think the thing, and this is a subtlety which I didn't really talk about, is you'll note that the theta that we had here doesn't have a T subscript on it. So I think a big challenge with using value-added measures of instructor effectiveness for like really high-stakes personnel policies is that they're noisy and they change over time. And well, you can't do this for someone's first time teaching, or even after you shouldn't probably do it the first couple times, because there's just so much noise and it's hard to extract the signal. And so I think what it can tell you is, here are some pretty broad patterns that are, these instructors are systematically doing sort of better than everybody else, and let's learn from their experience and what they're doing right. And I think that's where they want to go with this.
So in discussions with Phoenix, have they talked about then ways that they can do interventions, i.e. instructor training?
Yeah, absolutely. So I think that's going to be sort of the next. I mean, I think our interim first is figuring out what these instructors are doing. So that's why I think it's not quite actionable in the way that learning analytics is aiming for. But I think the next phase is aiming to do that, because I think even even this sort of the thing I somewhat mentioned offhand about whether having a PhD in math is a positive or a detriment to your ability to teach basic algebra. That is something that they can use to reassign sort of who teaches this particular course. And maybe those instructors are more effective at other or higher level math courses, or people that are more specialized, not the people in the general program. So that's something they can do sort of, but right now they don't really assign personnel to courses in any systematic way like that. So that's another sort of action item. So I think I think there's a lot more kind of better understanding of what's driving these patterns that we want to do before we can really make some actionable policies. But I agree with you that we don't want to take this and say we're going to use this to sort of just lop off the bottom. Yeah.
What do you think are the challenges of translating this research into a more traditional higher education system like in Michigan?
Yeah.
And that would be also different for research one university versus teaching focused universities.
Yeah. So the question was, what are some of the challenges applying this approach to other institutions? I think the two, I'm not sure which is harder in my mind, the two issues that I highlighted of the selection problem, of the fact that students take courses not randomly and can often know what the instructor is, who the instructor is when they choose to take it. So that's a big issue. I don't think that's I think that's overcomable. I hope it's overcomable, because I want to do that here. in that, there's some I think that's a challenge. But let me think how you would actually deal with that. I think the onus to do that kind of analysis is much more on the researchers to really understand the mechanism through which students are assigned to particular instructors, and trying to find a good setting that is going to give you something approximating randomization. So, and that might mean you've got this instructor that's teaching this course in these semesters and then randomly is on leave for a semester and then comes back. Well, then you could use that to at least compare that instructor to the one that replaced him or her. So I think the challenge is so that's a bigger challenge in other settings, but I think it's one that it's going to require more attention by the researcher. The other one about outcomes, I think, is also a problem, though. I think people have different views about this. I think on some level, like, the outcome that we all care about is like whether or not students graduate, and maybe like, do they have a GPA that's reasonable when they do? Like, that's kind of an outcome that many higher ed institutions share. There are other things about the experience that we care about too, but like, that's probably number one in my opinion. So that is actually, so I'm less worried about the outcome measurements. Yeah, so I think of that as not as a challenge as much as so the question was about tenure status of the instructors. I think that not as much of a challenge of the research, but rather that might be an important contextual difference or mediating factor. So it might be institutions that have a big range of instructors teaching courses, you might have a bigger range of effectiveness, or maybe a more narrow. I actually don't know which way that would go. Yeah. Yeah.
Do you have an insight of how big this impact of different structure is for different students? For example, some students, the teacher is kind of accessory, while the other is a fundamental part of the learning process.
Yeah. So great question. So if I can restate the question, how does have we looked at this by different types of students? You can imagine distinguishing between by sex or age or level of preparation coming into the course. So I think that's a great question. We have not yet. That's another area where I think we are going, and it actually speaks a little bit to this question that Stephanie raised about what are we going to do with this, because that's another thing that we can do. Is if we can find that certain instructors with certain characteristics are more effective with certain types of students than others, we could be much more systematic about who we assign certain instructors to. So this doesn't directly speak to that point, but there's a study that just came out on the effects of taking courses online versus face-to-face, and that found sort of big kind of negative consequences of taking a course online. But all of that was actually concentrated in sort of the less prepared students. The more prepared students, actually, there's no difference in their performance whether or not they take the course online versus face-to-face. So that, to me, says that the question of like whether online is good or bad is like not a good question. It's about for whom is it good or bad for, or what are those mediating characteristics. And so I think we could do the same thing here. And I think that's something that would be actionable also, that we'd like to do. That I think the power of having sort of a big sample with really rich data about the instructors and their students and how they interact could be quite useful there.
I think that also partially addresses this question. That addresses things like socioeconomic demographics or sort of prior course inventory. But I think he's getting more at the idea that some students have a strong preference for working with the book and having access for clarifications. Other types of students really need to work through examples many times before they start seeing students who are trying to get past the narrative of I can't do math, whereas others don't. And sort of have that barrier that different kinds of instructors kind of fit those types, in the types of in their methods and the supports they offer. And so I think that's a little more used.
Yeah, which is a great. It's a great point. I mean, so one dimension of just to restate, probably not as eloquently as you did. To restate is one dimension on which students differ is sort of the appropriate way in which the best way in which they learn, the environment, the way they interact with the instructor, the way they interact with the materials, and that could be a distinguishing feature. So in these courses, canned curriculum, same thing for everybody. There are little tweaks here or there, but not too much. You can imagine tweaking it based on students' preferred way of interacting with a course material. So that's another thing where I think the learning analytics could inform. So this is something actually, it's surprising, it's something that's a plug. An institution like Phoenix actually could be doing a tremendous amount of A/B testing. So they're running this course. I mean, I guess I never calculated like how many of these Math 208 classes are they running at every 5 weeks, but it's a lot. And they could be doing little tweaks here or there along the lines to the curriculum about who, which students are assigned to which instructors, or which students are assigned to certain types of methods of course environments. They're doing some of that, but not nearly as much as they want to, or as much as they should, I think, to answer that question. Yeah.
Statistical analyses of however you're defining standard deviation of instructor effectiveness, and however you're defining standard deviation of student success, be more standardized and less flexible the range of curriculum,
Yep.
be less effective the instructor.
Yep.
So everybody takes the same course is sitting in the seat.
Yeah.
That
That's
makes
right.
me again wonder how much if there's not a lot of latitude for them to offer the course according to which to shape.
Right. Yeah, that's a good point. I mean,
and that comes back to action.
yeah, I mean, the question of whether or not, yeah, no, it's a fair point. I think this is a setting where actually we think the instructors have little room to change the curriculum. That might be a component of effectiveness that we actually care about, which isn't quite captured here. But to your point, it seems to be more captured in the ground campuses than in the online, where you would expect more of that tweaking.
The idea of building in how can we pay more to keep certain instructors which are more effective and let others go. You may be letting highly effective instructors go that their effectiveness is cranked on the structure of the course.
That's right.
So you're actually shrinking your pool.
Yeah, I can see it either way. I mean, I think there's another study that found that essentially what you described, that like online sort of condenses performance variation, but both at the high end and at the low end, and it's of students but also of instructors. And so I think we want some variation, though ideally you pull up the bottom rather than cramping down the top. And it looks like the online format is actually doing both of those things. It's a great point.
All right, we're out of time, so let's thank Kevin again. I think the next step is a break and then off to tutorial.